Welcome to ClickMyProject.com.
Now we are going to discuss about the product cross-subject zero calibration driver drowsiness detection, exploring spatiotemporal image encoding of EEG signals for convolutional neural network classification. Now we are going to discuss about the abstract of the process. In this digital signal processing, this process deals with the analysis of EEG within the proposed framework has been carried out with the algorithm named as DWT, that is the discrete wavelet transform, for decomposition of the signal into one frequency of subbands, and then the set of features were extracted from the subbands to represent the distribution of wavelet coefficients. Then the reduction of the dimension of the data is done with the help of the feature extraction methods, such as the steps named as the mean, standard deviation and variance. By using this type of features, we can reduce the dimension of the features. Then these features were used as an input for the classifier, and then the classification is done for the data to predict the input as normal or drowsiness. If the data is predicted as a normal, means the message box will be pop up as a normal signal, or else it will be detected as a drowsiness, means it will be displayed as a drowsiness. The performance of the classification is evaluated to show the excellence of the classification process. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. At first step of the stage is input signal. At first the input is taken from the dataset. The dataset consists of lot of EEG signal, which having both the normal signal as well as the drowsiness signal. After getting any one signal from the dataset, the pre-processing will be carried out. In this pre-processing step, we have to filter the signal to reduce the noise present in that particular signal. Hence here we are using the FR for the filtering methods to reduce the noise in the signal. After the noise reduction, we just move on to the third step of the process, that is the signal decomposition. In this signal decomposition, we are using the wavelets by means of the discrete wavelet transform. The output of the discrete wavelet transform will be the four kinds of output. That is, the first one is the low frequency output, then the second one is the low high frequency output, then the third one is the high low frequency output, and then the fourth one is the high frequency output. By using this one, we have to convert the signal into one alpha, beta, gamma, theta and delta. After the decomposition of the signal, we have to extract the feature from that particular signal. The feature extraction will be carried out by means of the mean, standard deviation and then the variance of each signal. For example, we have taken the low frequency, means the mean of low frequency will be extracted, then the standard deviation of low frequency will be extracted, then the variance of the low frequency will be extracted. Similar to that, other signals will be taken. After the extraction of the feature, we just move on to the classification, that is the feature matching. Feature matching and then classification will be the similar only. In this classification step, we just identify whether the input signal is the normal one or else the drowsiness one. After classifying the data, we just move on to the performance estimations by using the accuracy, sensitivity and specificity. By using this performance estimation, we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first, open the Matlab 2015B and change the current directory. If you want to execute the process, just right click in the main_GUI.yum and select the option run. Now the user interface was open. In that user interface, you can see the several push buttons in the right side for the controlling axis, and then the several axes in the left side for the display purpose. First of all, click the button input signal. Once the button click, the dataset will be open. You have to select any one signal from the dataset. The corresponding signal will be shown in the axis 1. This is the EEG signal which we have taken from the dataset. After the data selection, we just move on to the next step of the process, that is the pre-processing. In this pre-processing, we have to eliminate the noise present in that particular signal. The filtered signal is shown in the axis 2 with the title of filtered signal. The x-axis represents the number of samples, the y-axis represents the amplitude value. After the signal filtering, the signal is decomposed by means of the DWT, that is the discrete wavelet transform. This figure represents the wavelet signals. After the conversion of the signals into a wavelet form, we have to convert the alpha signal separately, beta, gamma, theta and delta separately. After the separation of the signals based on the frequency bands, we have to move on to the next step, that is the feature extraction. In this feature extraction, the corresponding feature value is extracted by means of the mean, standard deviation and variance. That value will be shown in this table. This is the feature, otherwise known as test feature. After that, we just move on to the classification step. In this classification step, it will be detected whether it is a drowsy, means the message box will be pop up like this, identify as drowsiness. After that, the final step of the process is the performance. Hence, the performance will be evaluated by means of the accuracy, sensitivity and specificity. The values are displayed in the percentage.